Hello everyone, this is lesson 1.3, 6th grade math. Please make sure you copy this down. This should be written down in your notes. I'll say that again. This should be copied down and written down in your notes. This is not optional. This must be written down. Write a number as a product of prime factors and represent the product using exponents. So by the end of today, we should be able to find factor pairs, explain the meanings of prime and composite numbers, be able to create a factor tree and find prime factor numbers, and then be able to write prime factorization of a number. Alright, let's see if we can do this together. So question number 1, it says list the factor pairs of a number. So to list factor pairs of another number, ladies and gentlemen, what we're going to do is we're going to draw some rainbows. So factor pairs or numbers, basically we're trying to find the numbers that can multiply to give me 14, all of them. So that will always give me 14. So what numbers can I multiply that will give me 14? Well, to do that, it's an easy way. I'm going to write the number 1 here. I'm going to write the number 14 here, because I know 1 times 14 is 14, right? What's another number? Does 2 go into 14? Yes, it does. 2 times what number will give me 14? 2 times 7. So 2 times 7 will also give me 14. Does 3 go in there? Nope. Does 4 go in there? Nope. Does 5 go in there? Nope. Does 6 go in there? Nope. So it looks like the only factor pairs for this problem are right here. Okay. Let's try another one. Numero dos. Let's list all of the factor pairs. Same thing. So I know 1 and 26, because 1 times 26 gives me 26. Does 2 go into 26? Yes, it does, because it is an even number. So 2 times what will give me 26? If we know that off the top of our head, it's going to be 13. Can we think of any other numbers that might give me 26? Let's see. Does 3 go into there? Nope, because 2 plus 6 does not equals 8, and 3 cannot go into 8. Not 3, not 4, not 5, right? 5 times 5 is 25. 6 does not go in there. Nope, nope, nope. Not 7, not 8, not 9, not 10, 10, 20, 30. So it looks like the only numbers that can go in there are 1, 2, 13, and 26. A lot of this gets much easier when we know our multiplication tables. Alright, so let's try another one. Number 51. How do we know 51? Because it's such a weird number. We just gotta do our, look at our facts, and I'll print out a sheet of paper for you guys to have that. Alright, so I know 1 goes into everything. So 1 times 51, that's 1. I know 2 doesn't go into it because 51's not even, but I'll tell you right now, I know 3 goes into it. How do I know? Well, there's a trick to know if 3 goes into the number. If you can add them together, right? 51, 5 plus 1 gives me 6. If 3 can go into this number, that's how you know it will go into your original number. So 3 goes into 51. We just need to know how many times it goes in there. Well, good thing we know how to divide, so we're going to divide. 51 divided by 3. Does 3 go into 5? Yes, it does. 1 time. 1 times 3 is 3. 5 minus 3 is 2. Bring down that 1. How many times does 3 go into 21? That's going to be 7 times. So it looks like the factor pairs for 51 are 1 and 51, and then 3 and 17. How do I know that? You just got to know your multiplication, guys. We just got to practice, and we're going to keep on practicing. Let's do another one. Number 14. List all the factor pairs. So I know we have 1 and 18. I have 2, and what number goes into 18? 2 and 9, right? 2 times 9 is 18. I have 3. 3 times what? Oops. 3 times what gives me 18? 3 times 6, right? And what are the numbers that are left over? 4 and 5. We know both of those don't go in there. So the factor pairs for 18 are 1, 2, and 3, and then 6, 9, and 18. Alright, let's try another one. Number 5. Press pause if you can, and let's see if you can figure it out on your own. What number go into 36? I know 1 and 36. It's even, so it's 2 times what? 2 times what number? Well, we can divide, so let's divide. 2 goes into 3 how many times? 1 time. 2 times 1 is 2. 3 minus 2 is 1. Bring down your 6. Does 2 go into 16? Yes, it does. 8 times. 2 times 8 is 16. So you know it's the answer is going to be 18. 2 times 18. So we have 1 times 36. 2 times 18. Does 3 go into 36? Yes, it does. What was the trick to know if 3 goes into it? Well, we add them together. 3 plus 6 gives me 9. Does 3 go into 9? Yes, it does. So that means 3 goes into 36. Well, how many times does 3 go into 36? We have to divide. 36 divided by 3. Does 3 go into 3? Yes, it does. 1 time. 1 times 3 is 3. Let's subtract. 3 minus 3 is 0. Bring down the 6. Does 3 go into 6? Yes. How many times? It goes in there 2 times. So 2 times 3 is 6. So that means it goes in there 12 times. Does 4 go into there? Yes, it does. 4 times what number will give me 36? That's going to be 9. 9 times 4 is 36. Does 5 go into there? Nope. 5, 10, 15, 20, 25, 30, 35, 40. Nope, doesn't. Last one that does go in there is going to be what? 6. 6 times what number gives me 36? 6. 6 times 6 gives me 36. So our factor pairs for the number 36 is 1, 2, 3, 4, 6, 6, 9, 12, 18, 36. We're going to try one more and see if we can figure it out. I know 1 and 47 are factor pairs, right? Does 2 go into 47? Well, it's not an even number, so no. Does 3 go into it? Well, let's see. 4 plus 7. What's 4 plus 7? That's 11. Does 11 go into... Or sorry, does 3 go into 11? Nope. How about 4? Let's see. 4 times 10 is 40. 40 plus 4 is 44. 44 plus another 4 gives you 48. So, nope, not 4. What about 5? Let's see. 5 times 10 is 50. So that's too big. Let's minus 5. Gives you 45. So 5 doesn't go into it. Nope. 6 doesn't go into it. 7 doesn't go into it. 8 doesn't go into it. 9 doesn't go into it. 10 doesn't go into it. So it looks like the only numbers that go into 47 are going to be 1 and 47. And sometimes, ladies and gentlemen, this happens. And these kind of numbers where it's only 1 and the number itself, only one, these numbers are called prime numbers. The ones that have a lot of answers like this, these are called composite because they're formed of many numbers. So let's see if we can do some other steps. Now we need to do something called prime factorization. And what that means is we are going to turn this number into prime numbers. So we have to find prime numbers. To give you an example of some prime numbers, 1, 2, 3, 5, 7, 11. Some of you guys are like, oh, it's all the odd numbers. It's not, because right, we skipped 9. 9 is not a prime number. 13, 17, 23, and stuff like that. So those are prime numbers because the only ones that go into it are the number 1. So how do we do prime factorization? Well, we're going to create something called a factorization tree. Why do we call it a tree? Well, because it looks like a tree. I'm going to write the number 9, right? Then I'm going to draw this little tree. And I'm going to try to think of 2 numbers that can multiply and give me 9. What numbers would those be? Well, it would be 3 and 3. 3 times 3 is 9, right? So every time we multiply in this tree, because you're going to see times when you got a whole bunch of them, it should always equal your top number. So we finished the tree, but we did not finish the actual prime factorization. To finish the prime factorization, we just got to turn it into exponents. Well, let's see. How many 3's do I got? I got 2 of them. So the answer for this one is going to be 3 to the 2nd power. That is prime factorization. Let's try another one, see if it makes sense. 49. Alright, so I'm going to write down the number. I'm going to draw my little tree. Can you guys think of two numbers that if we multiplied them together would give me 49? Well, off the top of my head, I'm thinking of 7 times 7. Now, is there any other number that can go into 7? Nope, it's just 1 and 7, because 7 is a prime number. So that means we finished. Oops, what did I do? Now, all we need to do is make sure we put this in exponents. Well, I got two 7s, so that's going to make 7 to the second power. Alright, let's try a different number this time, a little bit bigger. Let's try, did I skip one? Nope, right here. So now we have the number 50. So let's see, what two numbers can I multiply to get me 50? I'm thinking of 10 and 5, right? 10 times 5 is going to equal 50. Not done. So is there any numbers I can go into 5? Nope, just 1 and 5. So we're done with that one. Prime is a 5 is a prime number, so I'm gonna circle it. I'm done with it. But 10 is not a prime number. What numbers can go into 10? Well, 2 and 5, right? 2 and 5 make 10. So is 2 a prime number? Yes, it was. Remember we said 1, 2, 3, 5, 7, 11, 13, and you start getting used to them after you memorize them. So we know 2 is a prime number, and then we also know that 5 is a prime number. So we're done. I'm going to circle them just so I know. So now I just need to put this into a multiplication problem. So they're all multiplying, right? So 2 times 5 times 5. So that would be 2 times 5 times 5. But isn't there a better way to write 5 times 5? Yeah. So it would be 2 times 5 squared. And that is your prime factorization. Why? Because these numbers are prime numbers. Let's try another one. 66. Let's see. What numbers can go into 66? Well, I'm thinking 11, right? Because 11 and 6, right? 11 times 6. If we look at the last problem, is 11 a prime number? Yes, it is. So we're done with 11. I'm going to circle it. But 6 is not a prime number. What numbers can go into 6? Well, we got 2 and 3. We know 2 is a prime number. We know 3 is a prime number. So now all I got to do is multiply these. The way you want to do your prime factorization is you want to put them in order. So 2 times 3 times 11. And that, ladies and gentlemen, is how you do prime factorization. Let's try another one. Number 13. It's not the 13th question we did, is just number 13. Alright, so now we have to put this back into a real number. So all that means we got to solve. Again, this is 2 times 2 times 5 times 5 times 7. Well, let's do this. What's 2 times 2? That's 4. What's 5 times 5? That's 25. So now we just got to show our work. What's 4 times 25? That's going to give you 100, right? And then what is 100 times 7? That's going to give you 700. Alright, let's try the next one. Number 14. Same steps. Let's write it out. We know that's 2 times 2. We know that's 3 times 3 times 11. Well, let's see. What's 2 times 2? That's 4. 3 times 3 is 9 times 11. Okay. So now let's just multiply. 4 times 9 is 36 times 11. Well, let's multiply. I'm going to break 11 into two numbers. I'm going to break it into 10 and then 1. So let's see if you can figure this out. What is 36 times 10? And then what is 36 times 1? We should know that 36 times 10 is 360. 36 times 1 is 36. And if we add those two together, you get 693. 396. Alright, let's try another one, ladies and gentlemen. This is number 15. Number 15. So for this one, we want to find the greatest perfect square that is a factor of the number. The greatest perfect square. So this is a trick question, guys, because it's really asking you something very special. So the greatest perfect square. So what is a perfect square? So 2 is a perfect square, right? Sorry, 4 is a perfect square. because that's 2 to the second power, which gives you 4. 4 is a perfect square. 9 is a perfect square, right? Because that's 3 squared. What's the next one? 16 is a perfect square. 25 is a perfect square. So as you see, where the numbers are getting bigger, let's keep on going. 6. 36 is a perfect square. Let's jump a few. 10 squared. 100 is a perfect square, and we got to get up to 240, so we got to keep on going. Let's jump another one. 144 is a perfect square, so we're not even close there yet, so we got to keep on going. Let's see. What about 15 squared? 15 squared is 225. We're pretty close now, right? Because we needed to get to 240. So maybe we can go one more up. Let's see. 16 squared. Let's see what that is. I don't know what that is off the top of my head. So let's multiply. 6 times 6 is 36. Carry the 3. 6 times 1 is 6. Plus 3 is 9. Put your place holder. 1 times 6 is 6. 1 times 1 is 1. And let's add everything up. 6 plus nothing is 6. 9 plus 6 is 15. 1 plus 1 is 2. So we have two choices. It says find the one that is closest using a perfect square. Which one is closer to 240? This one or this one? 16 squared or 15 squared? What do you think? Well, if you look at the numbers, 15 squared is closer. Good job. Let's find, well, I mean 256 went over, so I guess it depends on the question that they ask. If they don't want you to go over, 15 is closer. If they don't mind if you going over, 256. Alright. We'll skip that one. We'll skip that one as well. Alright, let's do number 18. Let's do this one in prime factorization. So let's do this. What two numbers will give us 144? That's going to be 12 times 12. I hope you guys knew that. 12 times 12 should give you 144. But now we need to break these down into prime numbers. So what two numbers give me 12? Well, that would be 6 and 2, right? 6 and 2. We know 2 is a prime number. So now let's break down 6. What two numbers will give me 6? That's 3 and 2. So we know 3 is a prime number. We know 2 is a prime number. So we know 3 is a prime number. And we know 2 is a prime number. So all we need to do now, ladies and gentlemen, is put them in order. How many 2's do I have? I have 1, 2, 3, 4. So that's going to be 2 to the 4th power. Times, let's see how many 3's I have. I have 1, 2, which is going to be 3 to the 2nd power. Alright, let's see it. Do we got any more questions? Yep, we got 2 more questions. Write the prime factorization of 243. Well, this is going to be hard because I'm trying to think what numbers go into 243. Well, 1 does, but we can't use 1. Does 2 go into 243? Well, it's not an even number, so it's not 2. It's not 5. It's not 10. I'm going to give you guys a little bit of hint. It is going to be 3. But what number times 3? Good thing we know how to divide, so let's divide. 243 divided by 3. Write it down. Show your work. 3 does not go into 2, but 3 does go into 24. How many times? 8 times. 8 times 3 is 24. 24 minus 24 is 0. Bring down the 3. Does 3 go into 3? Yes, it does. How many times? 1 time. So it's going to be 81 times 3 is 243. We know 3 is a prime number, so we're done. That means we got to break this one down. What two numbers give me 81? What times what gives me 81? Well, that's going to be 9 times 9. And 9 times 9 is 81. But is 9 a prime number? Nope. We got to break this down. So what two numbers give me 9? 3 and 3. 3 and 3. So now we just got to put this in exponent form. How many 3's do I have? I have 1, 2, 3, 4, 5, which means this is going to be 3 to the 5th power. Alright, let's try. How about this? We won't try another one. We'll just stop right here. Alright, ladies and gentlemen, I want you guys to try your best, and I will see you guys all tomorrow in class. Have a great day.